Hey guys, today we're going to be building this music visualizer with Three.js and we're going to use some shaders and some post-processing. Now, if you know nothing about shaders, I have a full 3-hour course here on YouTube. It's completely free. Go ahead and watch that first if you want to get started with shaders. Now, with that being said, before we get started, have a look at this thing that we're going to be building today. Story repo, and you can download this from the link in the description. Now, this is basically my 3 Webpack boilerplate, but I've added some extra files for this music visualizer that we're going to be building. So I'm going to run npm start. Of course, you need to run npm stall first, and when you run this, you'll get this rotating icosphere. All right, so when I go back to my repo, in the src folder, app.js is where the main stuff happens. So let's open that up, and here in app.js, I have some files. For example, here at the top, I import some shaders, and let's actually isolate some parts. So here where I create the geometry, I want to create some breathing room. So here, when we create the mesh, this is basically the parts that we're going to be dealing with today. So for the geometry, we have an icosahedron. Let's change that to a sphere geometry because that's what we're going to be using today. And let's set the radius at 1 and let's set the segments at 100. All right. And we're going to be using a custom shader today. So let's delete all of this code and let's change this to a shader material. So like that, and as you saw at the top, we have some vertex shader and fragment shaders. So let's import them like this: vertex shader and fragment shader equals fragment shader. All right, so let's open these up. So in the fragment.glsl, we have this basic fragment shader that is setting the color to green. And in vertex.glsl, we have this very simple vertex shader. All right. Now, with this, you're going to get this green sphere, and that's what we're going to be starting with. Now, to create the thing that you saw in the beginning of the video, we need a good noise function, right? So I often search for noise functions for hours, but here in this video, we're going to be using this noise function. Now, this is Gavoronoise noise, and this is a mix of Gavoronoise and Voronoi, I think. Read this share toy page if you want to. The link is of course in the description, but I really like this wave like shape that this guy has created. So I thought wave like shape with music could actually create some really interesting results. All right, so here in the right hand side, I have this code which is available, and here we're going to copy some of this code. So from the parts where it says define, I'm going to scroll down. I'm going to grab all of this code. When you see Gavoronoise 3, we're going to stop right at the end of that function. So we're not going to get Gavoronoise 4. All right, so let's copy that. Let's go into our fragment shader and let's paste this in. Sorry about that. Let's paste it in like this. And I think this should work fine, but let's also create some breathing room here. So what we're going to do is we're going to display some things here. So first I need to import a variant called vuv. So let's do variant vec2 vuv, and we're going to get the UVs from the vertex shader. So variant vec2 vuv here, and we're going to set the vuv to UVs. All right, so you write it like this. Now, what we're going to be doing is we're going to use this as the coordinates for our noise function. So we can write Gavoronoise 3 and provide VUV like this. And we should wrap this in a vec3 because this gives us back a float. So like that. And with this, we should get something. And yes, we still are rotating the icosphere. So let's come down here and let's delete this animate ico function. All right. So with that, you're going to get this noise thing. All right. Now, what we're going to do is we're going to change some parts of this code, but let's first take a look at this function. So this is a noise function which returns a float, and this is a 2D noise function. All right. So that's what we're going to be using. Now, there are a couple of parameters here that we need to change. So here in the F, I'm going to change it to 3 multiplied by pi. And that's what we're going to be using. So with the V, here it says there are going to be some artifacts with V equals 1, but actually the best result I got was with V equals 1. So we're going to set the V to 1. So we're going to set the dv to 0. So direction variability is going to be set to 0. And with that, we're pretty much done modifying this function. We're going to come back to it later, but yeah, with this, you're going to get this. Now, let's go to the part that this function is actually being used. So when you scroll down, we need to go into this part where it defines this noise. So let's copy this float noise and go into our shader and let's paste this in also. But we're going to be using the Gavoronoise 3. So let's change this to 3. And this is going to work fine. So let's go back here. We're also going to be using some other functions here as well. So here where it says map and NOR, we need both of these functions. So let's just copy them and let's just paste them here. Now we're going to modify this code. So you're going to be deleting the first line of this map function. Delete the third line as well. So all you have left should be this function, which returns 2 times apps. And let's also delete the if statement and delete this final line as well. So we're going to end up with this function, and let's also change this to 2. So essentially, this is how your map function should look like. And here in the NOR function, we're going to change something. So change this small value to 0.1 here in the E. And here change this 0.15 value to 1. All right. And that's going to be our NOR function. All right. So here at the main function of this shader toy, we can see how these values are being used. And this is the parts that we're interested in. So here at line 204, and here where it says light, we need to grab all of this code, this 3 lines of code essentially. We're going to grab all of that and let's copy that and let's paste it here in our main function. Now here we're just kind of copying and pasting the noise function that this guy has created, but we're going to make it unique and we're going to make it our own. So we have this light and we're just calculating the dot product essentially. Let's get rid of this max actually. So we don't need that. And let's also put this at 1 line. So this can be just defined like this. And let's output this R. Remember, the NOR function uses the map function, and the map function uses our noise function, and the noise function uses our Gavoronoise 3 function. All right, so this is how all of this is working. Now, we can return R like this, and what we're gonna get is an error probably. Let's see what it says. Okay, it says P is undeclared, so let's define P. Now, what P is here is essentially the coordinates. If you look into this bit of code here, so this is essentially VUV that we could use. So I'm gonna pass in VUV, and with this we should get a result. Yep, we're getting this. Very cool. Now, there is a problem here that you might already see. this is a beautiful pattern, and we're gonna animate it, and you're gonna see why this is beautiful. But here we have this discontinuity here, and the patterns don't align. Now, normally what you would see is you would see people using vnormal for this instead of VUVs, but here what I'm gonna do is I'm gonna hop back here, and we're gonna modify this Gavoronoise 3 function even further. So come to this line where it's defining this variable, this vec2 PEP, and here we're gonna delete this part where it says -h. All right. So with that, you're gonna get rid of that discontinuity. Now it's perfect. All right. So, and we're getting this very cool effect here, but the coolest part is animating it. So let's animate this. Now we're gonna hop back into app.js, and we need to actually define a uTime uniform to do animation. So here in the uniforms, I'm gonna type in uniforms, and we're gonna define a uTime, and this is gonna be an object with the value of 0. All right. So here in our animation loop useTech, we're gonna be updating it. So we're gonna write material dot uniforms dot uTime dot value equals timestamp, and that's what we're gonna be using. So here in the fragment here, to access that, you need to go at the top of the file, and you need to import uniform float. So that's going to be a float and uTime. All right. So here at the bottom, not at the bottom, but at this Gavoronoise 3 function, we're going to be doing some cool animation. And I did a bit of testing here, and I realized that if you animate this direction, this is going to give you a pretty cool result. So let's animate that. So let's add uTime here to this M, and this is going to go forever, and this is not going to give us a loop, but to make this work, we need to go into app.js, and let's divide this by 1,000 because this is just too fast. I'm going to show you what's happening right now. So you can see this cool animation. The lines are, increasing rapidly, and you get this cool morphing animation. Now, to actually see this properly, we're gonna use a sine. We could use a cosine as well. In fact, that's what I use for the final project. And with a cosine, it's gonna go up and go down. So the lines are going to increase, and they're gonna decrease at the end. Now this is very cool, but the coolest part about this is we can move this to the vertex here, and we can do some sort of displacement. All right, so before we do that, let's clean this up a bit. So we don't need this matrix 2. Let's just delete that, and let's also delete this function hash2b. We don't use that here. And let's also delete this int windows because we don't use that either. And that's gonna be it. So let's copy all of this code. Let's actually cut it, and let's move this to the vertex here. So I'm gonna paste it here, and let's go into our fragment.glsl, and let's also copy or cut this part and paste it here. So we're gonna paste it like that. Let's put the UVs at the very end, and that's gonna be it. Now what we're gonna do is we're gonna create a varying, call it varying float v pattern, and we're gonna set this varying to our noise function. So v pattern is r, and we can move this down, and that's gonna be it. So we can now go up here, copy this line, and copy and paste it here, and we can display v pattern, and we should get the exact same result as before. So we get an error. I think we forgot uTime. Yep. So we're gonna go up into our fragment here, and we're gonna copy this part, and we're gonna paste it here. So we need this uniform here, and that's gonna be it. So we're gonna get the result. Now this is not working. I know why, because we're using the VUV here, and we need to use the UV because here at the bottom we're setting the VUV. It's not defined at the very top here. So with that, you're gonna get the exact same results. But now what we can do is we can do some sort of displacement. So To do displacement, we need to create a vec3, call it position, call it new position actually. And we need to take the existing position and add the displacement that we want. Now, for displacement, we need two values. First, we need the direction. And the second thing that we need is how much are we going to push this vertex in that direction. So what's going to give us the direction? The normal is going to give us that direction. And we're going to multiply that by r, which gives us how much are we going to push this vertex in that direction. So we're going to use the new position instead of the position here. So new position here. And with that, you're going to get this displacement. Now, it's a bit too much, right? So we need it to be more subtle here. So what I'm gonna do is I'm gonna hop in here, and where we add this R, I'm gonna clamp this to be in the 0 to 0.4 range. I think that's gonna be fine. Let's see what's happening. Yeah, even more subtle is much better. So let's do 0.3, and I think this is fine. We can even do 0.2 if we want to. And yeah, this is much better. All right, so we're getting the displacement and we're getting this value from 0 to 1 as the color in our fragment shader. Now, the next thing that we want to do is colorizing this object. So to colorize a shape in Blender, normally you would use a color ramp in the shader node tab. So that's what we're going to be building with our shader today. Now, if I go back into our fragment.glsl, I have this macro that I can copy and paste, and this does the exact same thing as the color ramp. So I'm going to copy and paste this macro. Now, this also has a custom struct that we're going to be using. So this is a struct that holds a color and a position. So with the color ramp line, you have points, and those points have a color associated with them, and they also have a position on that line. So if the line goes from 0 to 1, they are positioned somewhere in the space between 0 to 1. So I'm going to write this goes in the range of 0 to 1. All right, so that's the position. Now, here I have this macro, which seems super crazy, but what it's doing is very simple. So we're going to input some colors, and this is going to be a color array. And the reason this is a macro is because that color array has a fixed length. And if I wanted to do a function, I needed to change that fixed length each time I modified the array. So I didn't want to do that, so we're using a macro here, and as you can see, I'm using the length function. Now, we're gonna get some colors within an array, and we're also gonna get an input position. So we're gonna ask, what position do you want to know the color of? So that's what this input position is. And we have a final color, which is a vec3, and we write that color that is in that position in that final color vec3. So that's very simple stuff, but how does this exactly work? So here I'm doing a for loop, and I'm walking through the points 2 by 2, right? So we're getting 2 points, and I'm checking if our position is in between those 2 points. And once I find where our input position is actually placed, I can get those 2 points that are adjacent to it, and I can take those and I can do a lerp between them. So that's all that this math is doing. It's very simple. Now we're going to be using this. So to use this, I'm going to copy this color ramp. And as I said, we need to provide a final color. So I'm going to call this color, vec3 color. And we need to now call this macro, and we need to provide an array with the color struct. So I'm going to write color with big C at the beginning, and this is going to be an array. So it's going to be an array of 3 elements. Let's do a quick test here, and I'm going to call this colors. And again, the same syntax here, but we're going to provide some parentheses here, and here we can define our colors. So I'm going to do a color struct, and this needs a vec3 as the color. So let's put this at 0, which is black, and the position is also 0, right? And here we're going to do color vec3 And let's do green. So 0, 1, 0. And the position here should be 0.5. And here at the final point, we're gonna do vec3, and I'm gonna do white, and the position should be 1. All right, so make sure you don't mess this up. And with that, we can now pass all of these in. So colors, and the input position that we need is actually we pattern. So that's the value that goes between 0 to 1 that we want to use the color ramp on. And we're gonna use the final color to write it like this. And all we need to do now is we need to output the color. All right, now this is very simple. It should work. We get an error. Let me see why that is. Okay, it says, all right, I see. We haven't provided a semicolon here. All right, and with that, you're gonna get this, which goes from a 0, which is black, all the way to green, which is in 0.5, and stuff like that, and it goes up to 1, which is white. All right, so we're getting the result that we want here. Now, to make this look beautiful, I have a code snippet here. So I've already designed the colors for you. So instead of doing this, I'm gonna paste this in, and this is a color array with 4 elements now. And we can define this main color later, but I'm gonna define it now. So vec3 main color, and we're gonna provide a vec3, and I'm gonna do a simple blue color. So something like this, and maybe bump the green up a bit. And yeah, we're gonna be using that. So you can now use the same thing. You don't need to change the macro or anything, because the array length is handled in the macro. So that's it. I think that we should get a result with this, and yes, we are getting something. And this is the color that we're going to be using. Now, this is not actually the final result that you saw, because in the final result, I think here at the vertex shader, so here when you do clamp, you need to actually invert this color. All right, so 1 minus R. That's what we're going to be using. So with this, you're going to get this, and this looks really cool already, but we're going to make it look even cooler. So what we're going to do now is I'm going to, again, copy and paste some code because this just saves time. So here in the fragment.glsl, if you need to copy and paste this part or look at it, I give you a moment here to do that. So here between the main color and this color's definition, I'm going to paste some code, and this is just essentially doing some sort of animation. And for this to work, we need to have this time variable. So here at the top, I'm going to define float time, and this is going to be equals to uTime for now. And this is going to just loop over different colors and do some sort of animation with colors. And with this, our main color changes from green to blue to red, and we can do all sorts of cool stuff now with this color. And okay, before we move on to the part where we plug the music into this object, we need to do some other things very quickly here. So in app.js, I'm going to come up here where we define a mesh, and I'm going to create a line segment mesh, or whatever you want to call it. So I'm going to call this wireframe equals, let's enter this, and wireframe equals new 3 line segments. I don't see that. Here it is. And here we need to use the geometry and the material again. So with that, you're going to get a wireframe. Now we can add this wireframe to the ICO. So ICO.add wireframe. And this is going to add this wireframe to our ICO as the child. And you get this wireframe now, but you can't see it because the scale of these objects are exactly the same. So what we're going to do is we're going to bump the scale of the wireframe just a little bit. So what I'm going to do is I'm going to create a const, and this is going to be just a small amount. So wireframe delta delta, and this is going to be equals to this amount, 0.015. And with that, we're going to scale up our wireframe now. So let's do that here actually before we add that to the ICO. So I'm going to do wireframe.scale.set scalar. All right. Now, what we're going to do here is we're going to set 1 plus wireframe delta here. All right. And this is going to slightly scale up our wireframe mesh. And with this, you're going to get this result. And this is pretty cool. You can see it's just a tiny touch. And this makes the whole thing just look a little bit nicer. Now, we have some weird issues with post-processing and stuff, so I'm going to disable it. So here at the bottom where we add these passes in, I'm going to disable all of those like this. And we get this result. And this is our final object pretty much, but now we need to actually plug in the music into all of this. All right, so now let's go back into app.js, and what we're going to do is at the top of this file, we're going to create a class. So I'm going to come here and I'm going to say class visualizer, and this is going to do all the visualizing parts and the audio stuff. So we're going to create this class, and what we're going to do now is I'm going to copy and paste the constructor to save time because these are pretty standard stuff. And here the constructor is pretty simple. We take the mesh and we take this frequency uniform name, and this is going to be our frequency uniform name. That's all that it is. And we create a listener, threejs listener, and we create a three audio loader and analyzer. All right, so that's all. Now the next function that is important in this class is the load function. So I'm just gonna copy and paste that as well. And here in the load we have the path, we set the buffer, we set the loop to true. We can even set that to false if we want to, but okay. We set the volume to 0.5. You can do whatever you want, and we play it at the end. Now, this is going to play the song, so let's just keep that in mind. And here I have another function, which is called getFrequency. So I'm just going to paste that in as well. And this just uses the analyzer to get the average frequency. All right, that's that. So we also need to write an update function. So let's write update, and within this function, what we're going to be doing is we're going to be getting the frequency. So const frequency is equals this dot get frequency, and this is going to give us the average frequency. Now we want to console.log this, so console.log frequency, and with that we have the full setup here. So what we're going to do now is we're going to come down here, and here where we add the icosphere, before we add it, what we're going to do is we're going to create that visualizer. So const visualizer equals, and we create a new visualizer, and we pass in the mesh, which is the ICO, and we pass in the name of the uniform. So I'm just going to call it audio frequency. All right. That's going to be the name of our uniform. And with that, we are ready to go. So we can do visualizer.load. And we need to now pass in a path. All right. So the path that we're going to be passing in is this. So we're going to import track. It's going to be any track from. And here I have a sounds folder, which you can import from, and I have this fire.mp3. I'll put a link in the description in case you want to see the original soundtrack of this, and support the artist. So here, what I'm gonna do now is I'm gonna come down here, and we're gonna load this track. And remember, this load function also plays the track. And with this, you're gonna get our audio file playing. And this is playing right now, but I'm gonna mute my computer completely to stop this from happening, because you don't want that playing throughout the tutorial. But Now, if we go down into the use tick hook, we can call visualizer.update, and with that, if you open up the console, you're gonna get some frequencies here. And as you can see, the range is kind of between 0 to 100 when you scroll down, and it also goes above that, but based on my experience, when it goes above 100 is when you want the real impact to happen. So so far it's just not going above 100. If we scroll down even more, yeah, it's basically between, yeah, here where it goes above 100 is where the main impact happens. So to capture that, I'm using this math. Let me copy and paste it. So here at this file, here where we update, I'm going to use this frequency instead of the previous one. So what this does is this subtracts 100. So we're disregarding anything below 100, and we're setting that to 0 essentially, because that doesn't matter to us. And whatever you're getting from this math.max function, we're dividing that by 50 to get a number between 0 to 1. And this is not always going to give us a number between 0 to 1, but it's going to be pretty good for our use case. And now if we log that, you can see we get a value between 0 to 1, always pretty much. And okay, that's all fine, but now we need to actually update the uniform, right? So what we can do here is, remember, we store this frequency uniform name. So what we can do is we also store the mesh. So what we can do is create this .mesh .uniforms and that's name. So the way that you would use that name is like this: you put brackets and you use this frequency uniform name or whatever, and you set this to an object with the value of 0. Now this is going to be at an initialization. We don't have to do this in update. So here at initialization time, we're going to create this, and here where we do updates, we need to update it. So we can do this .mesh.material and this material.uniforms, this uniform frequency uniform name .value is equals to frequency. All right, sorry about that, frequency. And here, let me check once again whether we got that right or not. We forgot to use material here, so mesh.material. All right. With this, you're going to update the uniform. So to see the impact of this, very quickly, we're going to go into the fragment.glsl. And what we're going to do now is we're going to actually multiply this by a number. And we're going to do 1 plus u audio frequency. And we need to actually define this at the top of the file. So we're going to do uniform. This is going to be a float, and u audio frequency. So, and let's also multiply this by something large, like 10, to really see the impact of this. And now I'm going to unmute my computer so that we can hear this. Let's reload the page. And here at the climax of the song, you can actually see the color changing. So there we have it. The color is changing based on the beat. So this is a very crude way of doing this. All right. So what we're gonna do is we're gonna do this a much nicer way. So what we're gonna do is we're gonna delete this part for now. We're gonna come back to this later. But in app.js, the way that we're gonna be updating this is, what we're doing here is we're setting this uniform to the frequency every single frame, and this gives us a bit of a harsh result. So we want this transition between frequencies to be smooth. So in order to do that, I have this code snippet here. So I'm just gonna copy and paste this part, and we're using gsap here. So let me import gsap. I think we can do it right here at the top of the file. Let me see what I did at the top. Yep, that's correct. And here we can actually store this in a frequency uniform. So store this part, const frequency uniform, and this. And what we're gonna do here now is we're gonna set the frequency uniform to this frequency, but now instead of doing it this way, we're doing it with gsap, and we're applying an ease out easing function to it. And now the values change smoothly. Now, okay, the next step is for us to ask ourselves, okay, how do we want to animate this? So I'm gonna go back into the fragment shader, and here I'm gonna multiply this by 1 plus U audio frequency. That's how we're gonna do it. And here I'm gonna replace this main color Vic3 with this. Now, this is gonna be a mix now, which is basically lerp. And we're gonna lerp between these two colors with the U audio frequency. So I can just give you a moment to copy and paste this part. And with this, what you're gonna get is very simple. Now, the next thing that we want to do is actually use this U audio frequency uniform in the vertex shader. So I'm gonna come up here and I'm gonna paste this in. So very simple stuff. And what I'm going to do here is where we do the displacement, let's actually copy this part and let's create a float displacement. And here I'm going to paste this in, and this should give us the exact same result as before. But now what I'm going to do is I'm going to add U audio frequency divided by 2. All right. And this is just going to give us a really nice, change in the displacement when the audio changes. All right, so we're gonna do that, and the next thing that we're gonna do is we're gonna come up to this Gavoronoise 3 function, and here we're gonna actually change some of the parameters here. Okay, so here what we can do is we can change this time variable with the frequency. So what I'm gonna do here is I'm gonna change this M to a Vec2 1.3. And here I'm going to use a variable called time, which does not exist yet. So we're going to create it. Let's create it up here, time. Float time equals uTime at the beginning. And we're going to have a time multiplier. So let's create it like that. And here I'm going to write mix of 1 and 3 based on a function that we doesn't have yet. So I'm going to write ease in quint, and I'm going to pass in the U audio frequency, and we're going to create this function now. So I'm going to come up here and create an easing function called ease in quint, and we're going to take an x, and what we're going to return is x times x times x times x times x, so 5 times. We can also do power, yeah, let's do that. So power x to the power of 5, and that's going to be exactly the same thing. So with that, you're going to get this time multiplier. Now, I think the name of this is a bit weird, so let's change this to time add or whatever. And what we're going to do now is we're going to add this time add to time, and we're going to now use time here, as you can see. So with this, you're gonna get some results, and when the audio changes drastically, this is gonna really come into play and really change that noise function. And now with this, you're gonna get this result, and when the beat goes up drastically, you can see this piece reacts, and you have the nice touch with the wireframes and stuff. But there's still one missing piece here, and that is post-processing. So with post-processing, we can make this look even cooler. So what I'm going to do here is I'm going to come into app.js, and we're going to create, we're gonna use a post-processing pass. So what I'm going to do here is I'm going to turn these back on, because I think they do help in the final look of things. But now we're going to create a new pass now. So what I'm going to do is I'm going to create a new pass, call it SoftGlitch equals new SoftGlitch pass. And what we're going to do now is we're going to create this. So here what I'm going to do is I'm going to add pass SoftGlitch. And let's create this. All right, so what we're gonna do is in the shaders folder, we're gonna create a new folder, call it passes. And within this passes folder, I'm gonna create a new file, call it SoftGlitch.js. And I'm gonna paste some code in. So this is gonna be the SoftGlitch pass, and this is basically an RGB shift pass, but I'm gonna be adding more stuff to this file later. So I thought I'd just create a new pass, call it SoftGlitch. All right, so that's gonna be it. And here we export SoftGlitch pass, so we can import it here like this, here at the top of the file. And what we're gonna do now is we're gonna enjoy this glitch. Now, if you just add this, nothing's gonna happen because you haven't set the factor here. If I set the factor of the SoftGlitch.factor to, I don't know, something like 1, you're gonna start to see the effect. You can see we have this soft RGBA shaking pass. And what we can do is we can make this react to the music. So what I'm gonna do now is in the update, what we're gonna do is we're gonna return this frequency. So let's return freq, and where we call update, we're gonna capture that. So const frequency equals this. So what we're gonna do now is we're gonna take the SoftGlitch.factor, and this is gonna be equals to, okay, so if frequency is bigger than 0.6, we're gonna return, I don't know, 0.8 or 0.7, I don't know. But if it's not bigger than that, we're gonna just do a very simple 0.1 here. And this is a very crude way of doing this, but if I go back, you can see we get this glitch effect once the frequency surpasses that 0.6 value. So you can see this is now giving us a very cool effect. Alright guys, that's gonna be it for this tutorial. I really hope you enjoyed this video. If you did, leave a like and subscribe to my channel if you're interested in 3D graphics and in Three.js. And hopefully this has helped you a lot. I really enjoyed making this video. So with that being said, YouTube thinks that you would like to watch these 2 videos. So watch them if you want to. And on that note, I'll see you guys next time.